good morning, good afternoon, good evening around the world. I see that there are participants that are in the siberXchange platform and there are participants that have logged in directly through Zoom, so that's fantastic. But our moderator Farwa will make sure that she parlays that to you. I'm only going to take 30 seconds topic. Today you're going to hear from Tanmay Bakshi, who is not only a good friend, initiatives across the world. The reason that I'm particularly excited for this session, who shares in his learning, he's someone who always keeps his door open. At any point of time, if you reach only him, his family, responds back to you and always looks to help. They understand but they understand the importance of literacy above all. Not just literacy when it comes to coding, the basic thinking skills that you need. Often people ask me, what is this, etc. For me, the best way to explain AI is anybody who works in AI, solver. And Tanmay is somebody who comes to the table knowing the problem and then as opposed to bringing solutions and then finding the problem. So today, Tanmay is going to be presenting overcome some of our challenges with teaching our kids to code, some of our challenges when it comes to going to present various options for you, and I'm very excited to hear from him. But before I turn it over to Tanmay, who is a good friend, supporter of the Durham College AI Hub, and somebody who made the at which Tanmay spoke. Mayor Collier, thank you for all of your support. I'll turn it over to you to say a few words to begin his session. Mayor Collier, over to you.
All right, well, thanks, Ali. Thank you, the AI Hub and the siberX team as well for working with us to bring an exciting session designed to educate kids and some of us adults as well on the importance of technology, data, and today's session will be on machine learning. AI and machine learning was new to me just over a year ago, and that's when I was introduced to the AI Hub and our presenter, Tanmay Bakshi. For those who know Tanmay, you know you're in for an extraordinary session, but for those that you do not know Tanmay, prepare to be inspired. From a very early age, Tanmay has been Ontario's resident expert in machine learning, algorithms, and coding. More importantly, he's become an expert in sharing his knowledge with others. After today's session, you will want to follow him on YouTube at Tanmay Teaches, and I understand he's even written a few books already that will help you get started in coding. It's an honor to be able to introduce him on behalf of the town of Ajax, Innovation Village, and Spark Niagara, our technology friends from across the lake. Thank you, Tanmay, for joining us and for continuing to help teach the next generation of technology experts. I'll turn it over to you. Thank you.
All right, so hello everyone. Thank you very much, first of all, to Ali. Thank you to the Honorable Mayor. I'm very excited to be here. My name is Tanmay Bakshi. I'm gonna go ahead and share my screen with you so you can see what I've got for you. There we go. And really what I wanna do today is I wanna go ahead and answer really a couple of fundamental questions about the world of code. I wanna answer questions like why and how should kids or the youth get into the world of code. And before I get into that, I do want to start off by saying a huge thank you to the team at the siberXchange Summit for putting together this event. I'm really excited to be here, as I mentioned. And of course, another huge thank you to the town of Ajax and Spark Niagara for making my session possible. Once again, this is really an exciting session to be a part of. But I know what you're probably wondering is, well, why me? You know, why am I holding this session today? And when I initially got in touch with the team at the siberXchange Summit, I kind of felt like this would be the perfect session for me to hold. And the reason I say that is actually twofold. Because I have firsthand experience, first of all, with actually getting into the world of technology at a young age. I've been working with technology for over a decade now, and it's something that I'm passionate about. It's something that I love doing. But at the same time, I also have firsthand experience working with students and their parents, and actually noticing the kinds of challenges or the issues that they face, or the sort of misconceptions that they have about the world of code and getting into it. So for example, some families or some students would think that coding, because the way it's taught, is a waste of time. Some of them treat it as this exotic subject that only geniuses get into. But really what I want to do today is break down those misconceptions and make it simple how exactly and why kids should learn how to code. And once again, it's not even just about kids, it's really everybody, I believe, should learn how to code. And I'll dive into why exactly I believe that in just a moment. So hopefully this experience that I've had can be helpful to you, and hopefully you're able to derive insight from it in some way. Now, I do want to start off by sort of giving you a tour of my journey into the world of technology and how I began working with this world of tech. And to do that, we're going to have to travel back in time by around 11 years, back to when I was 5 years old. Now, back when I was 5 is when I initially got into the world of technology. And I know what you're wondering, well, why? Why did I get into technology back when I was 5? And as you can imagine, back then, when I was 5, everything was just fun for me, right? Everything was just a toy that I would be playing with or interacting with, and computers were no exception to that. Computers, technology in general, they were just things that I enjoyed interacting with because of the fact that when I interact with them, they can do infinitely more things than any of my other toys or any of my other objects could. And so computers fascinated me in that way. And my dad saw that curiosity that I had, that fascination that I had for the world of technology, and he introduced me to the world of tech back when I was 5. Now, from there, my curiosity only continued to grow. As a matter of fact, I actually started to use different resources like books and the internet as learning resources to learn even more about the world of technology. And when I was 9 years old, I had my very first iOS application called T-Tables accepted into the Apple App Store. From there, I realized that, well, not only can I just create software, but I can also create content that enables other people to create their own software as well. And so that's why I started my YouTube channel called Tanmay Teaches, where I'd upload tutorials ranging in topic all the way from iOS app development and programming to math and science. And this YouTube channel actually made me realize something. It made me realize that there genuinely is a lack of resources for the beginners that want to get into the world of technology. And so I initiated my goal to help and reach out to at least 100,000 aspiring coders to really help them innovate along their journey of learning to code. In fact, I'm really glad to say that so far, I'm around 17,000 people there, and I'm always working towards this goal through numerous different media. I mean, I've mentioned my YouTube channel, but there's also the talks and the workshops and the keynotes that I have at schools, universities, and conferences across the globe, really making it so that people have the skills in order to implement technology where they believe it can have an impact. As a matter of fact, I'm also very glad to say that just last year, I had 3 of my books published in order to scale up this initiative. They are Hello Swift, Cognitive Computing with IBM Watson, and Tanmay Teaches Julia. As a matter of fact, on the siberXchange platform for this event, you can actually acquire these books at a discount. And before we continue, I feel like it's important that we take a step back. So we've already gotten to the world of Watson and Julia and next generation technologies here. So you're probably wondering, well, how did I get to this point in the first place? When did I start working with next generation technologies? Well, the answer to that is pretty simple. Back when I was 11 years old, of course, technology continued to fascinate me, but it wasn't as interesting as it was just a little while ago for me. And the reason was, if you remember, and if you relate this back to when I was 5, I got into technology because I felt like I could interact with it in infinitely more ways than I could anything else. But when I was 11, I started to notice those boundaries of technology. Things that technology can't do. Technology can't adapt to new circumstances. It can't adapt to new data that users generate. And I didn't really like that. But I'm glad to say that that entire conception of mine about the world of technology completely changed one day when I stumbled upon IBM Watson. and how it not only played, but won the Jeopardy game show against the two best human competitors on the game show, Ken Jennings and Brad Rutter. Now, when I stumbled upon this, I was just immediately fascinated by machine learning and next generation technologies. Today, it's easy to take for granted the technology that goes behind Watson, but you've got to keep in mind just how mind-bogglingly complex this software is. Jeopardy clues, and Jeopardy in general isn't just a regular game show. It's a game show designed to trip up humans. It has complex natural language with riddles, with puns, with wordplay that are difficult for even the best humans to understand. And now there's a computer system that's somehow able to relate this natural language in such a complex manner that it's able to beat the best human Jeopardy players. That's incredible. And ever since then, I have been hooked to implementing machine learning technology in essentially all of the different applications that I develop. And so machine learning technology is what I like to call next generation technology. And you're probably wondering, well, this next generation technology, what can we do with it? Well, what I want to do today is I want to go ahead and sort of show you two different perspectives on why and how we should be getting into the world of code in order to solve problems. Now, I believe that learning how to code has an impact on two levels. First of all, it has an impact at the individual level. It has an impact on the person who's learning to code. Obviously, you're learning new skills when you learn how to code. But at the same time, it has an impact on society and humanity as a whole when you learn how to code. And I want to start off by talking about what the advantage is for you as an individual, for your children, or for your students. So why should anyone learn how to code? Well, one thing that I believe is that when you learn how to code, of course, you are learning a skill. You are learning how to code, how to interact with a computer. But not only that, you are learning a fundamental life skill that is generic and can be applied across domains. And that is computational thinking. Computational thinking, in a way, is kind of just like a fancy way of saying applying problem solving in a way that you can use technology to solve a problem. You can use computers to solve a problem. But before I even get deeper into the world of computational thinking and why it's important, I feel like I should answer an even more fundamental question. Why should anyone learn anything in the first place? Right? Why do students learn calculus in school if they're not even interested in math? Maybe they're going to go in a completely different field. Maybe they want to go in, something that's not related to calculus in any way, something like history or art or language. Then why should they be learning calculus? As a matter of fact, there's actually a series of different videos that students will record with their teachers to sort of make fun of that fact, that they're not using the concepts that they learn in school in their everyday life. So, for example, let's take a look at one.
Mr. Christine, you have 5 seconds to name 3 things you use every day. 5, 4,
toothbrush,
3,
knife for peanut butter toast,
2,
and my car.
Funny how you didn't say calculus.
Ah!
So the thing is here, students don't realize one thing that goes behind learning itself. And that is that, of course, when you learn something like calculus, you are learning that skill of calculus. But not only are you learning those individual concepts, rather, you are building a generic mental model, a framework in your mind of how problems are solved, how humans in the past have taken problems that were previously unsolved and solved them with their ingenuity, with their creativity. That is the skill that you want to learn. I mean, personally, whenever I find something fascinating within the world of calculus or really any field like linguistics, I always end up asking myself, how did they come up with that? Now, how did they come up with this amazing and elegant solution to such a complex problem? In calculus's case, you would say, how did Newton and Leibniz come up with this solution to this problem where there previously was no solution? And what's amazing is when you ask that question and when you practice, when you build that mental model, you can apply it across domains. You could have learned a little bit of problem solving from math, and the next day you could apply it to language or to science or to essentially anything else. So when you're learning a skill like calculus, you're really learning the problem solving that goes behind it. And this brings us back to the world of code. I believe that it's important to learn how to code because coding is nothing but problem solving. Coding is the purest form of problem solving out there because the computer gives you very fundamental building blocks. And your job is to put together those fundamental building blocks in a complex enough way, in a creative way, such that you can solve a real world problem that humans face. And I mean, we could even take a look at a very simple example. Let's just say I were to ask you to calculate 2 plus 3 times 4. Now, usually you would just go in a calculator and calculate that. But let's just say no calculators on the table. You're only allowed to use your mind. Well, of course, if you remember BEDMAS, you're going to do 3 times 4 first, and then add the 2 to that result, so you're going to get 14. But here's the thing. Let's just say you want a computer to do that. Somehow you have to tell it to take BEDMAS into account. Now, the smart programmers behind calculators thought, infix, which is how we write these expressions, is really difficult to understand for computers. You got to deal with brackets and BEDMAS and all these different associativity things. You don't want to deal with it. So how about we deal with postfix evaluation? But postfix is difficult for humans to write. So what if we decompose this to 2 problems? We convert infix to postfix, and then we evaluate the postfix. Then from there, the programmers thought, what logic can we use to convert this infix to postfix notation, and then go from postfix to a result? And slowly but surely, they would build the first set of logic, build the second set of logic, and then write the code to implement that logic. When you have that code, there we go. You've got the final system. You have solved the problem. But there's something that I want you to realize here. And it's that final part, the part about writing code, that's simple. That's just an act. Anybody can write code. You could pick up a book in a couple of days. You would know a programming language like JavaScript or Python inside and out. So writing code is simple. But what came before that, the problem decomposition, the problem logic building, that is the art. That is the creativity that goes behind code. And that isn't just for code. You can apply that absolutely anywhere. And with that capability, you have the key to be able to innovate in any domain. And I feel like it would be great to take a look at a real example of someone out there innovating today with the power of their creativity and that computational thinking. And one perfect example, in my opinion, is my friend, Dr. Shuffy. Now, Dr. Shuffy is, according to Time magazine, the world's most watched surgeon. Why is that, you may ask? Well, Dr. Shuffy live streams his surgeries. Not only does he live stream them, he live streams them in virtual reality. So what that means is anybody, anywhere in the world, can just pick up a VR headset, put that on their head, and join his surgeries live, just like that. They're able to join the surgeries. And not only that, Dr. Shuffy is able to use this virtual reality, augmented reality technology as an educational tool. He has a company, Medical Realities, which specializes in combining education and healthcare, enabling surgeons to use the power of virtual and augmented reality to learn. Now, Dr. Shuffy is at the cutting edge. And today, people like Dr. Shuffy, surgeons like Dr. Shuffy, are exceptions. They're working at the cutting edge. They are innovating. Whereas most surgeons are, well, doing their job. They're doing a great job at it, but they're just doing what they were taught to do. But here's what I think is going to happen in the future. I believe that the norm is going to change. What defines a job is going to change. If you think about it, machine learning and artificial intelligence technology are getting more and more complex every single day. And that raises the question for a lot of people, isn't AI going to take away our jobs? And I believe that the answer to that is no. Artificial intelligence won't take away all our jobs. Rather, it's going to redefine what work means. It's going to redefine where and how humans are applied and how humans work. So in the future, every single job role is going to require creativity or innovation in some form or fashion. Surgeons like Dr. Shuffy are going to be the norm, because if you're not like Dr. Shuffy and you're not using your computational thinking skills to solve problems with the power of technology, well, a computer could have been doing your job better for you. And so I believe that we're going to redefine in the future what exactly it means for humans to work. And so what that means is that it's becoming more important than ever for us to be what's called technically literate, to understand what it means to communicate with the world of technology. And I feel like an analogy would be great here. So let's just say you're going on vacation. And let's just say you're going on vacation to somewhere like Spain. All right. Now you're going on vacation, and before that, of course, you would want to learn maybe the language a little bit to know some common phrases so you can interact with the locals. Or maybe you want to learn a little bit of the culture of where you're going, just so that you don't do something that's frowned upon, of course. So from there, just for a couple of days of vacation, you would be learning a little bit of a new language and a lot of their culture. And that's just for vacation. So it only makes sense that for something else that is all around us and is fundamental to every single thing that we do in our everyday lives, technology, you would want to learn its language. You would want to learn its culture. It's an understatement to say that technology is everywhere. Even just machine learning technology is everywhere. When you open up your phone, if you're using a personal assistant like Siri or a Google Assistant, you're using machine learning technology. If you are using the weather channel or the weather company in order to predict the weather, that is using machine learning technology. When you write an email and it autofills what you want to write for you, that is machine learning. All of this is powered by next generation technologies. And so technology is all around us, and it only makes sense that everybody needs to know the language and the culture of communicating with that technology. Because, as I mentioned, innovation is going to become a necessity in the future. And technology, well, without technology, it's going to be impossible to innovate. A perfect example of this, I believe, and this is a pretty shocking statistic, is called the gross world product, the total economic output of the entire world. And we've got data from 1 million BC to 2019. That's a lot of data. Now, let's just say you were to accumulate the total economic output of the whole world all the way from 1 million BC to 1990. That's over 1 million years worth of economic output versus just from 1990 to 2019. It's only a couple of years. From 1990 to 2019, we have created more economic output globally than we did in the million years before that. Think about just how incredible that is. And just to give you a sense of scale, the Industrial Revolution happened in the bottom bar. So even after that, from 1990 to 2019, we have had so much economic output. And this is thanks to the power of what I like to call exponential innovation, where new innovations lead to more and better and faster innovation. Think about the internet. The internet has sort of become the building block for a lot of other human innovations because it enables us to just generally work at an unprecedented scale that we never could have done before. So the reason that in the past couple of years we've had 1.38 times the economic output versus the million years before that is because of the power of exponential innovation. This means that problems are continually getting more and more complex. And so technology is becoming more and more of a necessity for us to be able to innovate. And there is one more real example that I want to give you. And this is something that fascinates me personally. I've been getting into the world of linguistics and linguistic psychology for some time. And I stumbled upon something known as Zipf's law a little while ago. And Zipf's law essentially dictates the distribution of the frequency of the usage of words within a certain language. So for example, no matter which natural language you take, in this case, we're taking a look at English, Spanish, and Hindi, the amount of times you use individual words within that language follows what's known as the Pareto distribution. Now, this was discovered by an American linguist. His name was George Kingsley Zipf. Now, you're probably wondering, how did Zipf come up with this back in 1940? Well, he did it by having humans painstakingly go through books and count the occurrences of words. Think about that. To find Zipf's law and to prove it to be true George Kingsley Ziff had to manually count the number of words in books and large corpora of English text. And to give you a sense of just how important his research was, it's become so fine-grained within this field of psychology and language that now, even to determine, for example, if chimps have a sense of grammar like we do as humans, for example, Noam Chomsky, who was taught sign language, we actually use Ziff's law and see if the chimp's language conforms to it. It doesn't. And so we came to the conclusion that no, they don't have grammar like we do as humans. What I'm trying to say here is not, Ziff's law is important, but rather I'm trying to say that within individual domains, within domains like language, experts like George Kingsley Ziff have saturated innovation. We've done almost as much as we could within those individual fields and sectors and industries. Now, if we really want to innovate, we've got to do cross-domain, inter-domain innovation, because that is nearly infinite. We've got to be like Dr. Shuffy, combining fields like education and healthcare to push humanity at the cutting edge. And because problems and solutions are getting more and more complex, it has become completely impossible to innovate without the power of technology. And since innovation is going to become a necessity, learning about tech is therefore also a necessity for the future. As a matter of fact, just for further affirmation, Mark Andreessen, the developer of the world's first web browser, says that in the future there will only be two types of jobs: those in which humans tell computers what to do, and those in which computers tell humans what to do. And so if we want to be on the other end of that spectrum, telling the computers what to do, we've got to make sure we can actually communicate with them, speak their language. And that's only possible when we teach everybody how to code. And so I know what you're thinking. Great, coding is important. I understand that. But what do we do? What do we do with this new knowledge? What do we do in order to learn about the world of code? And my answer might seem a little surprising at first. My answer is nothing. I don't mean literally nothing. I mean figuratively nothing. I mean we shouldn't be doing anything special. Because one of the greatest pitfalls about learning about the world of technology, in my opinion, that I've seen over the past couple of years, as I've actually worked with students and worked with parents and schools, I have noticed that people treat technology as this exotic, otherworldly subject that only geniuses get into, right? Or that in some cases, people think that it's a waste of time, right? You're just learning how to use Scratch, or you're just learning how to control a robot or move it. But what you've got to really realize is that no, coding isn't just for geniuses. And the only way that we can get rid of this misconception is if we start off with an open mind and we just introduce coding and technology like we would any other subject in school. Of course, education needs to be more personalized. It needs to be taught in a more example-driven fashion. But at the end of the day, we don't want to treat it like, all right, you've got your school subjects and then you've got code. It's this different thing. It's weird. We just want it to be normal. We don't want to attach a stigma to the world of code, which is why it's great to get kids into the world of code, in my opinion, because they don't have those preconceived notions. They start off with a completely blank slate with an open mind, and that is an incredible thing that you really can't get with people once they actually get that sort of those preconceived notions. And so really my three main sort of tips about getting into the world of technology in a way would be that, first of all, you got to start small, you got to start easy, and you have to start playful. When you do that, when you follow those three, I'm absolutely certain anybody can learn how to code. Now, of course, this is going to be different for everyone, but I believe that there's sort of like one example of a way to get into the world of technology that I believe follows a really nice learning path. For example, maybe you want to start off with something really simple like Scratch. And I know that at the top, at sort of like a top level, Scratch can just look like a game, but Scratch gives you a great computational thinking foundation without having to learn the syntax of a programming language. From there, you might want to evolve to something like Swift Playgrounds, where you're able to still have this simple game-like interface, but use the power of text-based programming. And then from there, maybe you want to get to something more complex, like the world of next-generation technologies through my book, Tanmay Teaches Julia, a language, Julia, which was purpose-built for the world of scientific computing. And so this is really how I believe we should be getting into the world of technology. Of course, it's different for everybody. Everybody learns at their own pace. And I believe learning, especially when it comes to code, should be personalized. And with that, before I go ahead and answer any questions you may have, there is one thought that I want to leave you with. And that is that my passion is to challenge myself to solve problems with the power of the code that I write and the technology that I create. And so my question for all of the educators, for all of the parents out there would be, what are the problems that your kids have the potential to solve? Help them find their passion, help them nurture their passion so they have the capability to solve the world's problems. And so with that, I would now love to answer any questions you may have. And I believe we can do this on both the siberX platform as well as the Zoom platform. So go ahead and send in any questions you may have. I do already see quite a few questions coming in. One of them is, which programming language should we begin with? That is a great question. As I mentioned, there are many different ways to get into the world of technology. One of them would be to get into the world of technology with something very simple. So for example, Scratch, this sort of block-based programming environment, which I believe is great for really young students who are interested in the world of technology and want to build that logical thinking foundation, but don't necessarily want to have to learn all the different syntax that goes behind code. So for those sorts of students, Scratch is a great way to start. If you do want to start off with something text-based though, there are two languages that I would recommend to get into. For today, I would recommend getting into a language like Python, because not only is it really simple, but it's also really sort of well documented, has a huge community around it, and is used for next generation technologies as well. To be future ready, however, I would recommend you also get into a language like Swift through a resource like Swift Playgrounds or my book, Hello Swift, in order to learn about the languages that will be used in the future, near future really, for next generation technologies as well. So I would recommend maybe even starting with a real programming language, something like Scratch, and then moving on to more complex things and really learning at your own pace. So that's one question. Next up, we say, let's see. So do you think COVID-19 is helping with learning, or are people nervous now? So that's a very interesting question, and the reason I say that is because just last Sunday, I actually held a webinar as part of my series called Tech Life Skills with Tanmay, and this webinar was on the field of education, where I had a bunch of different folks join me, including the CEO of Spark Niagara, Dino Miele, an executive director at the Manitoba Institute of Trades and Technology, and a regional school director at Zlearn in India. And we talked about the sort of impact that COVID-19 has on education, and from there, how we can continue to innovate within this domain to make it so we come back from this sort of crisis in an even better fashion. So I would say that COVID-19 initially had people really nervous and everything was just thrown off whack. But then we've slowly started to get into the hang of things. And in a way, COVID-19 is going to force us to innovate, force us to change, which previously we weren't. So short term, yeah, people were nervous, but in the long term, it's only going to make the system more robust than it was before. All right, so I'm also, just to make sure we don't miss anything from the Zoom Q&A, I'm going to take a look at that as well. Let's see. Let's click Q&A. Oh, do I need to stop sharing my screen for that? Let's see over here. All right. So what's the right age to introduce kids to coding or programming? All right, so we'll just take a look at questions from the chat. So the right age to introduce kids to coding or programming, I believe it's never too early, and it's also at the same time never too late to get into the world of code. Of course, you do want to start off introducing your kids to the world of code when they are able to, interact in at least some way with a computer and with technology, or they have that very basic understanding, which I do believe is important. So for example, I got into the world of technology when I was 5, life. And of course, I wasn't doing what you would consider, real sort of applications or coding. I wasn't following a curriculum. I was just having fun. I was implementing, for example, little SQL tables that would enable me to store the quantity of different ice cream flavors for an ice cream shop, or I would implement little calculators in C++. And this was really simple code, and all I was doing was building my logical sort of computational thinking foundation. So even kids as young as like 6 or 7 years old can get into the world of programming with something like Scratch. And then from there, once they've mastered that, once they feel like they are ready to move on to that sort of next step, that's when you can get them into more complex languages like Python or Swift, as I was mentioning. So what I would really say is that when you start coding, it should be something that you're passionate about. It should be something that the kids themselves are fascinated by, are curious about. And when they have that curiosity, that sort of when they want to move on to the next step, that's something that will come naturally. So that's something that I would definitely recommend. From there, another question: do you suggest any platforms for teenagers to learn with joy? So let's just say teenagers. In this case, I would say that it depends on what you want to do, but overall, there are two things that I can recommend. First of all, I've already said Scratch a lot, and it might seem like I'm just saying Scratch a lot, but really I do recommend Scratch for its computational thinking foundation. For teenagers, however, Scratch would be a little too simple. I would recommend getting into something like Swift Playgrounds. Because with Swift Playgrounds, you have a very gamified environment in which to learn how to code, just like Scratch, but at the same time, you are learning with a real programming language. You are writing actual code to achieve a certain task. Or, for example, if you take a look at my book, Tanmay Teaches Julia, that book introduces you not only to programming, but also gives you fun examples of machine learning technology towards the end, some of which are really fascinating, like generating neural network-based art. And so those are a couple of platforms that I would recommend for teenagers in specific. Another question: is having a good understanding of mathematics important for coding? So I would say that the reason a lot of people sort of mix the world of math and coding is because some certain sets of logic or some certain applications or use cases do require at least some mathematical understanding. So for example, machine learning would be one of them, vector graphics would be one of them, 3D animation, these sorts of things. But just for pure coding, which would be taking problems and being able to solve them with code, you don't necessarily have to have a good understanding of mathematics. One of the reasons, as I was mentioning, that people would mix the two would be because both of them are very reliant on that creativity and that problem-solving skill in general. However, I would say that it's not important to have, for example, great math skills for code or great code skills for math. They're both very reliant on that creativity to be good at, but they're not sort of dependent on each other. So, of course, it does help because then that increases the scope of the different things that you can do with the power of code. But at the same time, it's not a necessity. It's not a dependency. So again, if you're a kid or a student getting into the world of technology through Scratch, you don't need to have an important understanding of different mathematical concepts in order to code in Scratch, for example. So you can get into the world of code, you can solve problems with technology without having that mathematical understanding. Another question that I see, and this one is really nice: how can parents themselves begin to code? Now, first of all, before I answer that, there is one thing that I want to say, and that is that I have noticed in a lot of cases that one of the reasons students don't find technology particularly fascinating or something that they want to continue to get into in the future is because of the fact that those who are teaching them, because of the way that we actually have teachers teach code, a lot of those teachers themselves aren't proficient with the world of technology or with the world of code. They're sort of learning alongside students. And I believe that while it is important to have that experiential learning in the classroom, at the same time, it's also important to have someone who can answer your questions properly and give you a good intuition for the world of code. And so how can parents themselves begin to code? First of all, that is important. But what I would recommend is this: because you're an adult and because you have a little bit of the background already built that kids still need to build, you can actually start off with more complex resources. So for example, you can use resources like cognitiveclass.ai, which is a great way to get into the world of programming, getting into the world of development. You can use resources like my books over here that you can actually, again, get on the siberXchange platform for a discount at the moment, or you could use different resources like my YouTube channel, where I have free tutorials on all sorts of topics around the world of programming. And when parents themselves get into the world of code, first of all, not only is that great for the parent, I believe that is a lot better for the kids themselves, because then they are learning from people who actually have experience and can give them that intuition in a very natural way. And so hopefully that helps. So the 3 resources I mentioned, the cognitiveclass.ai, great course platform, as well as my books and my YouTube channel would be ways that I would recommend doing that. I don't see any new questions just yet. If you do have any, though, feel free to send them over. I see a couple of okay, I think we've answered all of these. Okay, so one question from Vidu is, please suggest how do I start with AI ML? Again, I would recommend using a resource like cognitiveclass.ai, or my 3rd book, Tanmay Teaches Julia, to get into the world of AI and machine learning. From either like a simple sort of using IBM Watson and different API standpoint, or even using the actual mathematical foundations. These resources help you with all of that. And then from there, how do you think kids should continue coding after learning these languages, since they're not in the companies to do programming? So my answer to that would be that when you're passionate about something, so for example, the world of code, right? So for example, when I was 11 years old, I wasn't working at any company in order to code, but rather I was interested in the world of code. It was what I loved doing. It was a hobby for me. And so I just continued to code. I continued to create applications. And you'll notice that with a lot of developers, because coding is something that requires a lot of passion. In their time off even, they will be working on different side projects and essentially just continuing to what would look as work, but really is just fun for them and for me, because I'm passionate about that world of technology. And so I believe that if kids are curious and they're interested in the world of code, they will continue to do so regardless of whether or not they're at a company. They will work on little projects. But if they're not, then if that's not something they were passionate about, then that's not something they should be continuing to work on in the first place. I believe you should be following your passion, whatever it is that you want to do. But at the same time, we need to give students equal exposure to all these different fields so they can find out what they're passionate about. And so I would say it's a sort of balancing act between those two. So hopefully that answered your question. All right, let's see. If you have any more questions, feel free to send them in. I'm not sure if we're getting any on the siberX platform. I can't check that, but if we are, I would appreciate if we could get that in the Zoom chat. Apart from that, in the Zoom Q&A, I don't see any other new questions. Feel free to just, we've still got a couple of minutes, so go ahead and send those through. And once again, I would love to answer those questions. Oh, looks like we are getting a couple of questions, so I'll go ahead and wait for those. Do I run any coding workshops? Yes, I do. So first of all, some of the ones that I've already done, just to give you an idea, every now and then I do a series on my YouTube channel where me and a guest will actually take a problem and implement it from scratch and solve it completely from scratch and live stream. That sort of process of decomposing the problem and sort of coding in the solution. But apart from that, this summer I am actually going to be holding coding workshops in collaboration with a couple of different organizations, one of them being Spark Niagara. And so I don't have many details to share with you right now in terms of how you can actually sort of sign up for this just yet, but I do hold these coding workshops. It is something that I'm working on, as I mentioned, in collaboration with Town of Ajax and Spark Niagara. They're coming up, so do keep an eye on my social media, like my Twitter and my LinkedIn, and I will go ahead and let you know when all of this is starting up. But yes, this summer I am going to be holding coding workshops on the Julia language and more, so feel free to join those. And we get one more question. What's the biggest obstacle when you begin coding? I would say the biggest obstacle is sort of changing the way you think about learning to make it so that you realize that within the world of code, things usually don't work on the first try. Personally, in my experience, I've sort of realized that whenever something does work on the first try, it's usually because you haven't tested it hard enough. And so just realizing that you need to be really perseverant, and that every time you make a mistake, you are gaining experience that's sort of preventing you from making that mistake again. Getting that perseverance is in itself a large challenge. And then from there, sort of in your mind, making the distinction between the programming language that you learn and the generic sort of computational thinking, that's also something that's really important to keep in mind. A lot of people, and this is something that I really have noticed, a lot of people will sort of overfit to say, I am a Java programmer or a C programmer or a Swift programmer, and they will specialize in a certain language. But you've got to realize that programming is a generic capability. It's something that you just learn, and then you can apply any language to. And so being able to learn that sort of generic computational thinking is important, but at the same time, being able to get that perseverance is also an obstacle when you begin with, but that you eventually get used to. A quick question is best language in IDE. Favorite programming language, Swift. Favorite IDE would have to be IntelliJ. IntelliJ for Go is what I use it for. Obviously for Swift, I would need to use Xcode, but then IntelliJ for Go code. And then how do kids learn coding in a developing country with limited exposure and resources? Again, this is where resources like cognitiveclass.ai come in. Even if you only have a really small Android tablet or a phone, you can still open up Cognitive Class, you can join courses, you're given free access to GPU machines where you can train machine learning models. It's really incredible what you can do today without having access to a lot of resources. Companies like IBM and Google are actually really working towards providing these resources to more and more people. So I would recommend using a resource like cognitiveclass.ai. And finally, do you think NLP can be developed for writing programs? I love this question, but I would have to say that unfortunately the answer is no. I'm forgetting which comic strip this was, but there's a really famous comic strip that answers this question, and that is that someone walks up to a programmer and is like, in the future we won't need programmers like you because we're just going to have computers write code for us. And then the programmer's like, oh yeah, sure, we can just define a spec that's really specific and tells the computer what to do, and just like that, we have the program that you're talking about. The other guy's like, yeah, that's exactly what we want. And the programmer's like, do you know what that spec is called? That spec is called code. And so it already exists. Telling the computer what to do is a really manual task. And the thing is, it requires creativity and ingenuity to come up with the logic to solve new problems that have never been solved before, something that machine learning isn't capable of. What we can do is create algorithms that help us translate that logic to actual written code to assist a programmer, but the programmers are still going to be there writing that logic in the first place. And so it wouldn't be used for writing programs totally, but it would be used to help the programmers, definitely. And so with that, I think, feel free to send any more questions if we've got some more time. I would love to answer them. But otherwise, let's see, any more questions? Or should we hand this back over to you? All right, I don't think there are any more questions. And thank you very much for joining us today, everybody. If you have any more questions, feel free to reach out to me on my social media. I would love to answer them. And thank you very much.